Hello again. In this short video, we're going to look into something called logic gates. Logic gates are the fundamental building blocks of any digital circuit or system. They can be used to perform any logical or arithmetic operations. So any binary operation for that matter. It could be logical or it could be arithmetic. We're going to see more into these operations later, but basically I want to say in digital circuits we perform three different operations, which are addition, multiplication, and something called flip or inversion or negation. So in order to perform an addition, we use something called an OR gate, and in order to perform multiplication we use something called AND gate, and in order to flip or negate we use something called a NOT gate. So let's start with an OR gate here. An OR gate, it could have any number of inputs. It could have anywhere from 2 to n number of inputs. It could have 2 inputs, it could have 20 inputs, but it always has only one output here. And so basically let's look at something with 2 input OR gate. This is what it's going to look like. Let's say we have 2 inputs A and B, and we have an output F, right? The function is typically written as F equals A plus B, or it is also written as A slash B. But in this class, we're going to use this operation primarily. Now, how does this operate? Let's look here. I have inputs A, B, output F, and if you think about these two inputs, the different combinations are 0, 0, 0, 1, 1, 0, 1, 1. We have seen this in class. So let's see. The operations are 0 plus 0, 0 plus 1, 1 plus 0, 1 plus 1. 0 plus 0 gives you what? 0. 0 plus 1 gives you 1. 1 plus 0 gives you 1. 1 plus 1 gives you 2. But we have only one output, and we cannot represent 2 in binary, which is a 1, right? So what we do is we take the maximum possible for an output. The maximum of 2 that we can represent in 1-bit binary is 1. So we write that 1 in we take the output 1 plus 1 as well. So it's going to be 0, 1, 1, 1. So if you notice, what we are saying is our output is equal to 1 whenever there is a 1 in any one of the inputs. Whenever there is a 1 in any one of the inputs, output is going to be equal to 1. That is an OR gate. Now let's look into something called the AND gate. AND gate is similar to OR. It could have any number of inputs, but it always has only one output. So let's say we have inputs A, B, we have output F. The output function can be written as F equals A dot B, or it could be written as A and B, or it could be simply written as AB. And in this class we use this or more predominantly here. So let's look into here. As we said before, inputs A, B, output F. Input combination 0, 0, 0, 1, 1, 0, 1, 1. Now let's try to perform this multiplication and see what happens. 0 times 0, 0 times 1, 1 times 0, 1 times 1. 0 times 0 gives you 0, 0 times 1 gives you 0, 1 times 0 gives you 0, 1 times 1 gives you a 1. So if we fill this truth table, one thing you will notice that is different between AND and OR gate is that your output equals 1 only when both the inputs, or all the inputs in this case, is equal to 1. Okay. The difference between an AND and OR is that in an OR, output equals 1 when at least one of the input is a 1 as given here, but in an AND gate, output equals 1 only when all the inputs are equal to 1. Okay, now let's look into the last gate here, which is the NOT gate. NOT gate basically looks like this, a triangle with a bubble at the output. So if you have input A, output F, your F could be written as A bar, or it could be written as negation A, or it could be written as A bar. So we use in this class, based upon the problem we are in, we could use this representation or this representation. So as the name implies, the output is just a flip value of the input. If I have input A, output F, so if I have an input 0, my output becomes a 1. If I have input 0, input 1, my output becomes a 0. That's it. So basically, we have, in this class, we're going to look into 3 logic gates for right now. The first one is the OR gate, and the second one is the AND gate, and the third one is the NOT gate. And one point I want to clarify, to bring to your attention once again, is that it doesn't matter how many inputs you have, any logic gate, the number of outputs is always equal to 1.